So in today's lecture, I will be I will be proving that convert the following integral. I will be converting the following integral equation to a differential equation. So this integral equation I have to convert into differential equation. G of s is equal to 1 plus integral from 0 to s t minus s g of t dt. I'll turn the page. So same equation I've written it over here also. Consider this as 1. Now differentiate this equation with respect to s. So what I'll get, g dash of s is equal to, if I differentiate 1 with respect to s, it will be 0 because it is a constant, plus d upon ds into this I'm differentiating. So now what I have to do is I have to use Leibniz rule over here. I have to apply Leibniz rule over here, okay? So apply Leibniz rule. Leibniz rule. So I'll turn the page. Next, I have given you all the Leibniz rule over here. And this part, integral from 0 to s. Now see, Leibniz rule is here. That is, this part is of this. So integral is from 0 to s. So what I have done is integral from 0 to s I have to put dou by dou x. So here it is with respect to s. So integral from 0 to s dou by dou s t minus s. Now this t minus s g of t dt, plus this is what I have taken to be upper limit minus s g of s. This instead of t you have to put s now. This upper limit will come here, okay? And then ds upon ds, because this is with respect to ds, and here the formula you can see the upper part beta is here because of beta, and it is beta here, okay? So that's why I have put here like this. Next is minus. In the formula it is given minus this. Now alpha part, the lower limit. So 0, this is my alpha, minus s. So wherever there is t, replace it by 0. So then this is with respect to ds. So okay. Now what I will get is g dash of s. Now this g dash of s is equal to, now what solution we got over here, we will write it here. Integral from 0 to s, write it as it is. Now this was with respect to s, right, ds. So it is constant, so it is 0, minus s is there, so it will be minus 1. So minus 1 into g of t dt. So s minus s will be 0, so the entire term will be 0. Here also 0 is there, so the entire term will be 0. So plus 0 minus 0. So what will remain? G dash of s is equal to integral from 0 to s minus 1 g of t dt will remain. That thing I'll have to write it here. That one I have removed. So g dash of s is equal to integral from 0 to s minus g of t dt, and consider this as equation 2. Now differentiate this with respect to s again. So I will get g double dash of s, double derivative, no? So this is equal to d upon ds. So differentiate this again with respect to s, and then you have to apply Leibniz rule again for this one, and I will get something like this. G double dash of s is equal to integral from 0 to s dou by dou s minus g of t dt plus minus g of s minus 0. So now this I have to differentiate with respect to s, so it will be 0 because here s is not this, so it is constant, so it will be 0, which I have plugged it over here. Now this is equal to integral from 0 to s, 0, why? Because here constant, so 0 dt, minus is because of this g of s, okay? And finally what I am going to get is minus g of s. So after this I will turn the page. So that is what I will get is g double dash of s. Now g double dash of s is equal to minus g of s. That is G double dash of s, I will bring this term this side, so it will become positive, plus G of s is equal to 0. Now to get initial condition, put s is equal to 0. If I put s is equal to 0, what in equation 1 and 2, what I am going to get? So this is my G of s. First, if I put, where is my equation 1? Yeah, if I put s to be 0, what I am going to get? If I put here 0, and if I put here 0, the limit will be entire, see, everything will be 0. So what I am going to get is G of s is equal to 1. So that's what, yeah, so G of 0, because s is 0, so it's equal to 1. And G dash of 0, that is what is my second equation. In second equation, what I'm supposed to put? The limit, if I, okay, 0 only, right? So G dash of 0 is equal to, if I put 0, the entire integral will be, everything will be 0 over here. So if the limit is, both the limit is 0, then everything is 0. So the G dash of 0 will be equal to 0. So that's what I got here. G dash of 0 is equal to 0. Let me write down 0 over there. It is not 1, okay, it is 0. So here we are done with today's lecture. In the next lecture, my next lecture will be on boundary value problems, and the derivation and some problems will be there. So here I'll end up my lecture, today's lecture.